we can get started here. So your screen. Okay. The length of the sides of a rectangle are A and B, where A is greater than B. So this is A and this is B. The sum of the lengths of the two shorter sides, which is apparently B, and one of the longer sides is 36. So it says B plus B, that's the two shorter sides, plus A is 36. What value maximizes the area of the rectangle? So the area of the rectangle is A times B. And what you have here is another formula that you can use. Like this right here becomes 2B plus A equals 36. And they want the value of A. So the best case here would be to solve this for B. That way you're putting this equation into this other one here. So B is equal to 36 minus A all divided by 2. And that you can substitute in here. So this is an equation for the area. The area is A times 36 minus A divided by 2, divided by 2. So that is 36. Well, let me actually do this a little bit. So you're going to multiply in the A, and you're going to divide it by 2. So that's 18A minus A squared divided by 2. Do you have any idea what this is a graph of? Parabola, yeah. So because there's no C value, this thing goes up and goes down. We need the vertex. So this is minus 1/2 A squared plus 18A equals 0. Do you remember how to find the vertex when it's in this form?
H over K, or negative H over.
So it is H comma K when it's in this form, but it's not. So it's minus B over 2A. The problem is that the A here, and they tend to do this a lot. I'm remembering this now, is they tend to use the letter that you want to use in the problem. B is the coefficient in front of the middle term. And A is really this coefficient here. So this equals negative 18 over negative 1, which is 18. So the A value here, where it reaches a maximum, is 18.
How did you get the 36 minus A over 2 again?
That's solved from the equation that they give you. They say that the sum of the lengths of the two shorter sides, that's B and B, plus one of the longer sides, that's A, is 36.
So why is it minus A then?
You're solving this equation for B. You're subtracting A to the other side, and then you're dividing it by 2.
Oh. Okay.
So let's talk about the skills that this one relies on. Let's see if we can work through some of those, and then maybe I'll give you one with some different numbers in it. One of the skills here is being able to use the formula to find the vertex. So in a quadratic, you have ax squared plus bx plus c equals 0, and the x coordinate of the vertex is minus b over 2a. Right? Do you remember that? Is that?
Yes.
Okay, great. So now in this problem, the quadratic ended up being 18a minus 1/2 a squared. And this looks to maybe to you, this looks very different than this up here. But it's still a quadratic. It's a quadratic in A. So to find the vertex is the minus the value in front of B. B is the one that's in front of the power to 1 term. So see how that's the 18 here? And then 2, and then A is the value in front of x squared in front of the a squared term. Well, that's negative 1/2. So this becomes negative 18 over negative 1, which is 18. let's try another one here because I think this is an important skill. I want you to find the vertex or the exponent of the vertex for the following. 12 minus 12x minus 1/2 x squared. Go ahead and find the vertex for that, please. So did you get minus 12 over -1 or 12 for the x coordinate of the vertex?
Isn't it? It's b over 2a, right?
That's right.
So wouldn't it be 1? Oh, you have to move that.
Yeah, so this is ax squared, this is bx, and this is c over here.
That's what.
And it can be in any order. And that's what we're doing. We're going to do a few of these to see if we get it.
I need another one.
All right, let's do another one here. Let's say the equation is let's see 32x squared minus 64x equals 0. What is the vertex of this one?
Is it 1?
It is. Okay, it is minus 64 over 2 times 32, which is 64 over 64, which is 1. Okay, so let's try another one. Let's say it is 4b minus 2b squared. So this is a quadratic in b, and you have to train yourself to say, well, it's not b, it's really x. Like, I don't want you to write this, but it is 4x minus 2x squared, because writing it is slow, and you don't have that much time there.
2 over 8. 1/4 or 0.25.
So what is your b value here? It's 4 minus 4 over 2 times -2.
Wait, don't you move the? Doesn't the b value? Isn't the b value? Oh.
You could rewrite this, and that's why it's confusing, because it's in b, it's instead of a. But the b value is the one in front of the linear term, which is the 4.
Okay.
So let's do another one here. Let's go 8a squared minus 2a. I want you to find the vertex of that. So this is a quadratic in a. If it helps, you can write ax squared plus bx plus c above it, just to help identify the terms.
2 over. Is it not possible to get fraction for these?
You can. This one is minus a -2 over 2 times 8,
Yeah,
which
I
is
got
2 over 16, which is 1/8, and that's totally reasonable,
okay.
possible.
That's what I got.
So let's get back to the one that you were given. It was like let's go 4b minus 1/2 b squared. So this is a quadratic in b.
see now? Okay. So that. So 4.
Yes, this is -4. That's your b value over 2 times -1/2, which is -4 over -1, which is 4. Okay, so here's what I'm going to do. I'm going to snip in the question again, but I'm going to change one of the values and no multiple choice. That way you can see if you think you got it here. I'm just going to change that to so let me paste that in here, and we're going to change that to 48. Okay. So let's just start by having you draw the picture.
Okay.
So it says that A is greater than B. So which side is A? Is the top A, or is this the left side A?
The top.
The top. And you might want to label it all. What is the area of this rectangle?
A plus A plus.
That's the perimeter.
Oh.
The area is A times B. Okay. Okay. And that's it's asking for that.
Oh. Okay. So.
All right. So now it says, I'm sorry, I scrolled past. It says the sum of the lengths of the two shorter sides. Which is the shorter sides?
The B's.
B. So B plus one of the longer sides, A, is 48.
Right.
So now you have a choice here. You can solve this for A or B. And this is actually something I didn't focus on, but it wants you to find A.
Okay.
And if you solve this for A and put this back in here, you're going to have your answer for B. That doesn't help you. I mean, it's an extra step. So if you can, you want to solve this for B, because then when you put it back into here, you only have A's.
Right. Okay. So move the A over. Minus A. And then divide by 2. Divide by 2. So B is 20. What is that? 24 minus A over 2. Is that right?
Yeah, so B is equal to 48 minus A over 2. Okay, so that goes over here. The area is,
Do you not do 48 divided by 2?
you have to divide them both, though. It's not a choice. They're both divided by 2. So it's A times,
Well, can you list it as B equals 24 minus A over 2?
yes.
Oh, yeah, you did that. Okay.
So now this is where we kind of were working all those problems. Now you have to find this is a parabola, and the value that maximizes it is right there, which is the A, which is it's really X.
So it's 24 negative over 1, 2 times negative 1/2. 24. 24.
Yep. Okay. I have a problem that's like this, but let's not do that right now. And we think we've done it a few times. So let's move to the next one here. So snip. All right. Two data sets are shown. Oh, I didn't give you the answers.
These are the worst.
The answers are here. Let me get those real quick.
Well, probably the worst because I don't know how to do them, but
Yeah, if a number is selected at random from data set X, what is the probability that the selected number is also in data set Y? Ooh. This one is written in a way that I'm actually not sure what it. I don't think it's written in a way that's very clear, but let me just read the solution here to make sure I understand. Okay. So do you see that all of the bottom numbers are 5 here?
yes.
Okay, that's somewhat helpful here. The number of values in Y is kind of the second part of this. There's the numbers that you care about over the total number of numbers. So the bottom is 5 because there's 5 down here. So when I say care about here, it's the thing that it's referring to. The selected number is also a number in data set Y. What does that mean? The number is also in data set Y. Like without, you don't have to use any fancy words. What does that mean to you?
How many times it appears in Y?
Okay, so like give me an example of a number that appears in Y that satisfies this. Or give me an example that satisfies this, I guess, part.
Well, like 4 appears twice, so you put 2.
Okay, so maybe it's still not clear. So five is in there. This other 5 is in there, and 8 is in there. So this means when it says also means it has to appear in X and Y.
Oh, so they're saying like how many, like which have overlap between the two.
Yes, and that's what's meant by that. How many do you care about?
Okay.
So the problem here is I don't have a great I guess I can make up one, but so let's say X has the numbers 1, 2, 3, 4, and 5, and Y has the numbers 3, 4, 5, 6, and 7. And let's try to ask. Let's look at the question the same way. So it says, basically like how many are in both sets?
5. So bottom number is 5. Denominator 5. And then 3, 4, and 5.
So see how these overlap?
Yeah.
So it's like if you pick a number in X, there's 3 that are in both out of how many numbers are in Y, which is 5. Now let's say, let me undo some of this because I want to work with this data set. Let's say that this becomes 8, and let me add in a number here like 9. Okay, so how many numbers overlap?
Well, it's still just 3.
Still just 3, but how many total numbers are there in Y?
6.
6.
You go by the number in Y.
Well, because it is, but that's the way it's written. It says, what is the probability that the number is also in data set Y?
Okay.
That's like your pool of numbers. Again, this one's written really poorly. I don't think I would have understood what it was asking for at first glance. Let's do a few probability questions here. So let's say I have a jar here, and I've got 4 white, 3 blue, and 5 yellow. What's the probability of selecting a white ball?
4 out of 12.
Okay.
So 3. No. 1. One.
So there's 4, and why is it 4?
One
It's
third.
because
1/3.
right, it's 1/3, but it's 4 because that's the ones you care about. That's the ones that matter. Out of the total is the 4 plus 3 plus 5, which is the 12 and the 1/3.
Right.
Okay, now what's the probability of getting a white and then a blue?
7 out of 12.
So this is, I haven't made this clear. If this means like you do this and then this, so they happen together.
Like you wouldn't add up then?
Well, it's like an and event. It's probably of white and then a blue.
So 1/3 and 1/4. I don't know. Is that how you read? I don't know how you correct it.
Well, we've got the white down. The white is 4 out of 12. Okay, but then the blue. Well, how many blues are there?
3. So it's
3.
1/4.
But then haven't you taken one out of this jar? So there's now 11.
Wait, how did you get 11?
Well, didn't you pull a white one out? When you pull a white one out, how many are left over?
But when did we pull a white one out?
Well, first you take a white one. You take a white one out, and then you take a blue one out.
But you're taking 4 white out.
No, you're only taking one. You're pulling one, but there's 4 that are good for you. Okay, so this has been, we haven't you haven't seen this before. Okay, so let's make a much simpler example, because this absolutely needs to be clear. So let's make a much smaller jar. There's a white, a blue, a blue, a blue, and then a yellow. The probability of selecting a yellow here is 1 out of 6.
Okay.
And the so let's pose a scenario. Let's say I want to know the probability that you get a yellow and then you get a white. So this is the probability that you get a yellow, which is 1 out of 6. But then what's the probability of getting a white after a yellow? So if you take a yellow, it's gone. Do you agree with that?
Yeah.
So how many white are there? There's 2, but there's 5 total.
Right. Okay, I get that.
You get that? Okay, great. So now let's do another scenario here. You have a jar and you have green, green, white, blue, blue, blue. What's the probability of selecting a blue?
3 out of 6. So 1/2.
Yes, so it's 3/6. Okay, but now I want to know what's the probability of getting a green, but I want it like after you get a white. So what's the probability of like that's assuming you took a white out. So what's the probability of getting a white ball? Well, there's 1 out of 6. Do you follow that?
Why don't you take the blues out now?
Because we're not interested in the blues. We're interested in the whites.
But wait, can you scroll up a little so I can see the last example?
Well, this is a different problem. It's a different scenario altogether.
But in that one, didn't you you went by how many the yellow were, right?
Yeah, there was 1 yellow out of 6, but here you're taking a green one out after you take a white one out. So we're trying to like work through it. Like after you get a white one, how many green are there?
Well,
Like
there's
you took
still 2.
there's 2, but how many total are there?
Well, 5, I guess.
5 because it's like it's literally pulled out. We're not connecting on this, and I think I guess you've never seen this, so we
Well,
probably.
I get it, but why don't you do the blue in that case? Like, why do you not exclude the blue? Or like in the very first problem, why
Well,
did
you can't see them though. You have no idea what's in there. You just know that how many there are. Like you're pulling one out, and you're hoping you pulled out one of the ones that you wanted.
So in the very first one, I don't remember which one it was.
This one right here.
Right. Why do you only take? Wait, where was it? Oh, 3 or 3/11ths. Oh, wait. Why are you only taking one? I guess it's blue out, right?
Well, this was the scenario where you first get a white one and then you get a blue one. So
Right.
there are 4 whites in here out of 12, but to get to the blue, that assumes that um, you took a white one out.
Uh-huh. Okay. I like sort of get it.
Okay. Okay, let's move to another question here and see if we can make some more progress on this. So this is one of those questions that refers to both. It gives you like some information that it refers to two different things. So at a um, at a science museum, they host a fundraising events for no more than 650 people. All right, so let me just jump down to this. If 200 member tickets were sold, how many non-member tickets were sold? Okay, well, they tell you the total profit, and like I didn't even read this, but I'm guessing that that's that right there. And if 200 member tickets sold, was that X or was that Y? Well, that's X because I can go back and just read what I'm or look for what's necessary. So that's X. So all of a sudden, this problem only has one variable left in it. 8125 equals 20 minus 12.5 times 200 plus 40 minus 12.5 times y minus 3000. So you in theory should be able to get an answer for this armed with a calculator. You should be able to get there. Now there's a lot of places that you can mess up. This is a number, this is a number, and then you can move this to the other side if you want. But see if you can come up with that with your calculator there.
Plus 3000. Um,
Okay, so I got y is equal to 350.
I'm almost there. 1 second. 11 9 6 Yes, I got the same thing.
Great.
Okay.
Okay, so that's how you do part A.
Okay.
All right. So let me get back to the next question here. So the next question refers back to, oh, it's an interpretation thing. That's not super helpful. Okay, we did that one. That was a substitution. Okay.
Wait, what was wrong with this? The second part of this one?
It's an interpretation, which is, I mean, it's other than just giving you the answer. I guess we could talk about it a little bit. It just, because you're not going to get this question again. So it's even if we talk about the ideas in it, it's maybe not always helpful. So they're asking what do you mean by this 12 minus 20 minus 12.5? Okay. And I'm
So
not
that
sure here. So the tickets sold for $20. The other tickets sold for $40, and the cost to rent the museum was $12.50. Okay, so what this represent is their profit. Like they sell it for 20, but it costs them $12.50. So
that's just for members.
yeah, but the other one is for non-members. So the 20, like they could ask you, what is the 40 minus 12.50?
So is that the cost? No, that's not the cost of the tickets sold.
It's the increase in the total profit for every additional member ticket sold. The 40 minus 12.50 is the non-member profit.
How is it every additional? Is that because of the where does the
Uh,
every additional come in?
Well, it because it's being multiplied by X,
That's okay.
that's why it's. I mean, it probably should say
Yeah,
X,
that's why I was like,
but it doesn't. I mean, they kind of.
okay.
All right. Okay, so the next kind of question, we did one. Okay, here's a new question. This one's definitely not a calculator question. This is one of those examples of something that, I mean, it's here, but it really has nothing to do with a calculator. So, which of the following is equivalent to the square root of 4x for all x greater than 0? So you got a couple options here. This one's just testing, like, do you remember what this symbol means? So the square root of x is the same as x to the 1/2. And if you have more than one thing, like if it's the square root of a times b, that's square root of a times the square root of b. You could also write it as a to the 1/2 times b to the 1/2.
Okay.
So now how do we do this one? Well, this is the square root of 4x. So it's the square root of 4 times the square root of x. The square root of 4 is 2 times the square root of x. Well, none of those are there, but that is a 4 and that is a 4, so it's not that one. From some of the stuff over here on the right, you can probably see that it's x to the 1/2 power, which is why it's letter A.
Okay.
So let's try one. Let's try one like what is the square root of 16x? Why don't you reduce that for me, or give me some other variation on this?
4x. 4x to the 1/2.
It is absolutely 4x to the 1/2. Okay, so let's just increase difficulty here a little bit. Let's say it's the square root of 4x over the square root of 8x. Let's do 16x squared. What would this be? What would, and it's really two questions. It's what's the top and what's the bottom.
Yeah. 2x to the 1/2.
So we already done that's 2x to the 1/2
over 4x, because square root of x squared is just x, right?
Yep, 4x. So does this reduce? That's kind of where we're at here. Does this reduce?
Do the 2 and the 4 cancel? So it'll be.
Yep. So where does the 2 go though? Does it go on the top or the bottom?
Wait, what do you mean? Where does the 2 go? Wouldn't it be x to 1/2 over 2x?
It is, but then you have to deal with the x. So the x is cancel. Like there's a rule for exponents. Do you remember that? If it's x to the n over x to the m, do you remember what that becomes? You subtract them.
So you subtract 1/2 minus 1.
Yes.
Okay, so that's you have to multiply by 2. So it's wait, I'm confused. So
what is the value of n in this problem?
What, 1/2? 1/2 minus 1, right?
Okay, so what is 1/2 minus 1?
-1.
-1/2. So this piece that I'm circling, it becomes x to the -1/2 over 2, but it's usually not written that way. So you have to move down to the. Go ahead.
By doing that, you get rid of the x on the denominator?
Yeah, they combine.
Oh. Oh, and then you move it down. Interesting. Okay.
All right, so let's try another one of those because I think that's got some important skills there. Let's do the square root of 9x over the square root of 16x squared.
So that is next over 4x. Wait, so do you multiply? I got 3x to the -1/2 over 4. So then do you multiply the 3 and the 4?
Should be +1/2 first of all. because it's there, and then on the bottom it becomes 4x.
How is it positive? Don't you subtract 1?
You do. So it becomes 3 over 4, and then it's x to the minus 1/2.
Yeah, that's what I.
Okay. I didn't follow. And then from there you would move it to the bottom here.
So do you multiply the 3 and the 4, and then like do like 1 over 12x?
It would be it just becomes 3 over 4x to the 1/2. You just move it to the bottom.
You just move the x to the 1/2 to the bottom. Okay. So it's only 1 if there's a.
Yeah, there's just they're just like this.
It's only a 1 if there's nothing in front of the x. Okay.
That's right. Okay, so let's see if we can find another question to look at to get some more clarity here. It looks like they sort of come off the difficulty, like they kind of ramp, the difficulty ramps up and then it comes down on these exams. Like this one is just it's either like a kind of a, there's no work that goes into it. You just either have the answer or you don't. There's really only 2 answers that are even sort of reasonable here for you. And it kind of depends on, do you understand what it means for something to go up by 100%? So if you buy something at $2 and it goes up to $4, that's 100% increase.
Because it's doubling.
Well, so if you buy something at $3 and it goes up to $6, that's the same thing. So yeah, a good way to put it is a 2W would be 100%.
Right. Okay.
Okay. So the one, like the one gets you back to the original, and the 60 is the 0.6 is the increase here. That's why this is correct. Now, this is a good time to remind you of the percent increase. Go ahead.
I don't get how. Sorry, I get the 2W part, but I don't get how you got 60 from that.
Well, it would have to be 2 here for it to be up by 100%. We agreed that, and 160% is bigger than 100%. Okay, so if something went up by 100%, it goes up by a factor of 2. This is not a factor of 2; it's a factor of 1.6. So 160% is more than 100%, so the factor would have to be bigger than 2. Okay, let's do this another way. This is not the correct way to do it, but it will help. So let's say you buy something.
Sorry, why is 16 not a possibility?
Well, I guess it is. I mean, I see why it's here, but it's the wrong decimal place. It would be 1.16 if that was correct.
1. Oh, okay. I gotcha.
Okay, if you buy something at $100 and it goes up by 1.6, it becomes $160.
Right.
So the percent increase or decrease is a known formula. It's the new minus the old over the old.
Okay.
This is your new price. This is your old price. So it's 160 minus 100 over 100, which is 60 over 100, which is 0.6. And to convert from a decimal to from a decimal, there you multiply by 60. Or by 100, I'm sorry, by 100 gets 60.
Okay.
So this you could remember, but it's slow. What I was trying to get you to see is that if you go up by 100%, it has to double.
Yeah, I get that.
So 1.6 is not double. 1.6 is less than 2.
Right. Can I see the problem again?
Yeah, let's go up and look at it again.
So double. Oh. So for that to be double, so it wouldn't be increasing then, is what you're saying.
Well, it is. It is. It just it double is a factor of 2.
But if it was greater than 2, it would be 160 then? 160%?
If yeah, so like if something goes up by 2.6, okay, like let's say it was 100
Mm.
and it went up by 2.6, a factor of 2.6, the new price is 260. The new minus the old over the old is 260 minus 100 over 100. That's 160 over 100. That's how you get the 1.6 factor. Or times 100, that becomes 160%. But it's not a 1.6 factor. It's 2.6 factor times the original.
I still don't get the shortcut that you did.
Well, the shortcut is the multiplier. Like what if you're multiplying?
Like I get the new minus old thing, because that's
If you're multiplying, if the number is between 1 and 2, it's it's between 0 and 100% increase. If the number is greater than 2, then it's a more than 100%
right.
increase.
Okay. So for the answer choices that they gave us, since it was, wait, what was the number again? Can you? So since it was 1.6, it can't be 160 because that's greater than 100. So it'd have to be 60.
It's between 0 and 100%. Yeah.
So that's weird. Okay. And the reason it's not 40 and 16 is because that's not the right. Well, those aren't the right numbers.
Right.
Okay. That makes more sense. So if it was like 2.1 or something like that, it would be like 210% would be like
Yes.
the right answer.
Well, no, if it was 2.1, it'd be 110%.
Two. Oh, because it's the point. It's because it's the point.
Yeah,
One.
1.6 is 60%. 2.6 is 160%. So 2.1 would be 110%.
Why? Oh. Okay. Yes. Okay. So then 2.2, 120, 2.3.
Yeah.
Okay. Yeah, I get it. Okay. That took me a while to get.
Okay, we'll have to end here. We'll try to do better next time. I don't think this was super effective, but we'll try to make some more progress next time we work together. I'll send out the notes and the screen recording here shortly.
Okay, thank you.
You're welcome. Bye now.